Spec-Driven Development. So my latest shiny thing is Spec-Driven Development. Had some actual tangible experience with it. As Carl said, I've been a developer for longer than I can remember. And spec development isn't a new thing, but AI has turned everything on its head and given us incredible opportunities, but also along with it, incredible challenges. And this is one of the most tangible, practical, real world applicable ways I've found so far to actually tame the beast and get the best out of AI, which, as most of you know at the moment, is non-negotiable and shows up everywhere. Okay, just to cover the obvious. Spec-Driven Development, SDD, is not a new acronym. It isn't new. It's always been good engineering practice. Some of you are probably thinking that it just sounds like good engineering practice, and it is. What's changed is that AI has raised the cost of doing the planning upfront, moving the thinking to the beginning, which used to be a nice to do thing and often a good idea for larger projects. In fact, almost essential for a senior. But now with AI, it's become essential. If you don't do your thinking upfront, AI can generate mountains of technical debt in minutes, hours, and whatnot for you, and kind of silently fail at scale. So you end up with an architecture and an app that is totally useless, unmaintainable, not what the client asked for, but perfectly legible, looks good, they even run. So without a spec up front, basically, you're not slowing down AI at all. You're just giving it ambiguity. And it delivers on that. It is an autocomplete machine. And if you give it ambiguity, that's what you get out the other end. It's garbage in, garbage out. That is also something that has never changed and really never will. So yeah, traditional workflow, developers drive straight in and often the magic lives in their heads. AI assisted workflow, without a spec, AI just fills the gaps rapidly and really convincingly. And yeah, as it is there, it can be coherent and elegant, and often is. AI is excellent at producing elegant but useless code. Spec-driven development, it just keeps you as the decision maker. Us as the engineer. We are the engineer. We'll get to who owns the code later. I mean, the short answer is obviously you do. So there's no real debate. But your thinking gets amplified. Your pace of movement gets amplified, and there's no more guessing. It's basically a heck of a lot more interesting and a lot more satisfying. As I said, so AI amplifies what you give it. If you give it ambiguity, that's what you get in spades. If you give it clarity, then you get great. So yeah, if you give it vague requirements, missing edge cases, security blind spots, or poor architecture, or you don't even specify the architecture, it'll guess and your results will not be what you want, and you are still responsible for them. And that's not a position anyone wants to be in. So you state your intent, you be clear about it. You write a good spec, or if you're blessed, you get a good spec from a client. I'll show you that in the first example. Yeah, you try and do a review of the specification. You work with the AI. This is not saying you need to produce the bulletproof spec upfront, not at all. You say what you know as well as what you don't in the specification. You work with the AI as a more senior, more expensive, more capable model to work through the spec until you are both happy with it. And only then do you start with actual implementation. And the other thing to mention is the spec is not a write once, file and forget, as so often happens traditionally. It's a living argument. It's a living document that gets updated as you go. As you go, you will discover bottlenecks and problems and constraints and things you can think about or cover, and you deal with them in the moment, but the spec updates. So it's a rolling record of everything that changed, all decisions made, all paths not taken for good reasons, which are often forgotten 3 months down the line in a development project. How to write a good spec, just 4 general things. So brain dump everything you know. Things you know you can do, things you know you can't. If you know the client is price sensitive, mention that. If you know the client is allergic to AWS or allergic to Azure, mention that. That obviously locks things down greatly. All non-negotiables. If the client wants something, and what are the priorities? What can be dropped if this is a time-constrained project, and what can't? Get the AI to question you. It's educational, but it's also, the AI will surface things that you didn't know. So it helps guide you through your thinking. Sounds trivial unless you actually tried it yourself, but the models these days are incredibly capable at walking in step with you and highlighting things that you may not have thought about, and you can do the same thing to the model. Lock the non-negotiables, obviously, but say that in the spec. and then define done. Edge cases. What does success look like? The model doesn't know that. The AI doesn't know that. There might be tangible things that the client is looking for that are apart from the obvious and the app works. So edge cases, particularly test criteria, things like that. Anything that would prove the work is finished. If you were standing in front of the client, you include that in the specification.
Ewan, I take it that these points here are more than just these are the characteristics of the process. That is a bit of a process framework to follow, isn't it?
It is. It's the simplest possible one. Obviously, you can go into a lot more detail for each one of these things. But this is the recommended process based on the original spec-driven design, but with a highlight in terms of the options that AI gives you. Number two isn't possible without AI. You'd have to sit in a room with all the developers, everybody brainstorms, someone plays the contrary angle and someone plays the client angle. Hopefully the client is there, and you go backwards and forwards, and you maybe do discovery sessions. You might still do discovery sessions before this begins, but whether or not you do, this will give you a good framework. This way you won't forget anything fundamental. You might not have a lot to start with, or you might have everything to start with, and either way it's going to evolve. That's not the question, but this will set you off.
So for the traditional business analyst or systems analyst, this would probably be very familiar in terms of going, what do I know? What do I still need to know? How do I start to define that? And how do I put that together before I even engage what would be the development activity?
Yes, it's what a business analyst would love to happen in every case, but hardly ever does. And it highlights them and exactly their approach, their skill, their talent at unpicking requirements that the client might not know they're asking for, but are actually asking for, or constraints. The client might ask for something that is actually very expensive and hard to do and violates the terms of their budget. So highlighting that upfront is great. There's nothing to say you can't come up with a spec and give it to the client and ask them to have a quick pass as well, or include them in this process by all means.
So for our business analysts, systems analysts, and even those developers that fancy themselves as analysts, probably a good slide to screenshot and go, this is where I start.
Yes. But just to highlight, this is definitely not something you hand to a business analyst. As a developer, you own the code, you own what comes out of this, you own the constraints, not just at the technical level, but you can't implement them if you don't understand the business level with all of these requirements. So that's key too. This is the entire end-to-end team that gets involved in this process. It might go in stages or it might be done at once, but everybody's involved. That's the only way you get the best out of it. And the better the spec, the better the input, the better the output.
Test.
Okay, so real world examples tell of two applications, just two recent ones that I've done and I think highlight the process nicely. So the first is a client that asked us to generate a chatbot, basically. It's a occupational health and safety application. They don't want users on the floor of a warehouse, for example, to have to carry around a tablet or a laptop or to fill in paper, but everybody on the floor has a phone. They take pictures in any case and they WhatsApp each other and everybody has a phone. So everyone's got WhatsApp, at least in this country. So everyone can interact with a chatbot. So what they wanted basically was a well-defined process where if there's a near miss, something shocking could have happened but didn't, someone avoided it somehow or pure blind luck, you can log it and record it, and then you've done your duty from the occupational health and safety side of things, and it's saved in the background and you can generate reports saying in this warehouse there were 2 or 3 near misses in this particular month at these hours with this product, whatever the details are. And it's useful. So there's a front end, which is WhatsApp basically, and a web interface for generating stats, and a back end, obviously, which is APIs and a database to store all the information. And also, if there's an actual incident, then it gets a bit more involved. You need to take a photo and things like that, because something actually did happen. Likely someone got injured, or a piece of machinery got injured and broken, whatever. But the point is that the process is very well defined. And in this case, the client gave us a spec which was very detailed. It listed exactly what the users would see and the workflow. None of the technical constraints, they're not a technical client, but the specification for how the app should work, what options the users were presented with, was very black and white. This is very rare in my experience. This hardly ever happens. But in this case, the client put a lot of thought into it upfront, which makes this a lot easier and an ideal candidate for your first foray into spec-driven development. I try and encourage you, if you're trying to do this on your own, see if you can find an opportunity like that, even if it's a project of your own that you want to do, and start with this simplest approach and go from there. I can actually share the document itself if you think that would, I've got an anonymized version of the spec, Carl, if that's worth it to actually share.
Yeah,
But
perhaps we hold on that for a moment, and maybe we'll come back to that at the end of the session.
okay. Okay, so as an experiment, I tried, at least in this, where you keep the tasks, because you're obviously your spec, the very first step once the spec is complete, or at least is complete and ready to go, is break down the specification into tasks. So in this case, I wanted to use an external system. So you can use something like Jira or ADO, Azure DevOps, which has the advantage of giving the client a view on all of the tasks, and they can add comments to the tasks and they can track them as they progress and as you get through them. More useful if there's more than one developer, I would say, and a client who actually will get involved in this level. So literally just asking the agent, that I didn't mention. So I'm a Claude fan by and large, basically. I think the models are smarter and generally better for code development at the moment, but obviously that might not apply in 15 minutes time, because this is a dynamic environment. So I literally just asked the model to break down the spec into tasks, small pieces that can be delivered, tested, and proven to work, and then store them in Azure DevOps. So there's no MCP server for Azure DevOps at the moment, which is sad, but it doesn't slow the agent down at all because there's an API and it's well documented, as most of Microsoft stuff is extremely well documented. So the model has absolutely no problem, as long as you give it authentication, to call Azure DevOps and to go through the spec, break it down into tasks, and in a couple of seconds, list all of the tasks in Azure DevOps, as I've shown in the screenshot here, which is great. And then as the process proceeds, the next step is implementing. So you drop down a model. For example, you will use a more expensive, capable model like Opus for Claude, or ChatGPT 5.5, one of the bigger, more smarter thinking models, to write the specification. Costs more in terms of tokens, but the more effort you put into the specification, the better the outcome as a whole. Then when you're ready to implement, you switch down to a much faster, much cheaper, cost-effective model, something like like Sonnet or Haiku. One of the smaller models, the benefit there is not only do they work a lot faster, the bigger models are slow. You are going to wait minutes, sometimes up to 15 minutes for an outcome, where Sonnet will return it in seconds, and something like Haiku will, do it in sub-seconds often for you. And then those models, as sub-agents, run off to the source, which they already know how to access, grab the next work item, and you guarding all of this, as this is not an automated process. Once you're more experienced and you have a bigger backlog and the framework around all of this is more mature, by all means, you can look at automating a lot of this. But in the beginning, you are responsible for the code. You need to approve the order that the tasks are done, see them through, watch the agent as it does its work. It generates all of the boilerplate, the crufty stuff, the crud stuff that's not much fun for developers to do, and asks you questions when necessary. If you've got your spec right, there will be very few questions asked, which is also something that I didn't expect in the beginning. It's the models are extremely capable at implementing what you've defined properly up front.
Ewan, sorry, just maybe a moment there for the rest of us that are not as deeply technical as you. Perhaps we just trace back. So in order to get to the point of having tasks within DevOps, effectively you would have built your first round in terms of the spec, following the framework process that you have described. Then you're utilizing an AI agent of the nature of Claude in order to break down that spec into individual tasks that comprise the build out tasks for that particular project. Is that right?
Yes. Since the model, yep.
And then within each of those tasks, I take it there's a detailed enough specification for that component of the overall thing in order for code generation to then become feasible, as that's the input to the next step.
Yes, you can do it that way. And I think that's pretty much the default for most people. At least it makes logical sense to me. But you can also, the spec can grow to either fragment into pieces or phases, and you can list all the tasks with the requirements for those individual tasks as a subsection for the spec. So the spec starts with the holistic version of what needs to be developed, and then goes into detail for each and every task. And then the system can read from that as well. So it doesn't matter where the information comes from, but the models are extremely capable at easily breaking down a spec into tasks and looking at dependencies to work out which one should come first, and then creating tests for those tasks, and then implementing them one at a time.
But again, that's coming down to a really well-defined and well fleshed out specification is going to result in a better detail in terms of the task levels that are then created in something like DevOps as the next step in.
Yes, yes, that everything is key. That spec is garbage in, garbage out. The more detailed, you can obviously go too far. I mean, if you're writing pseudocode in your spec, then you've gone too far. You want to be writing business requirements and dependencies and architecture decisions. But the models are extremely capable about breaking that down into implementation tasks, particularly the models that are good at code. That's what you do. You give them a spec. Normally, it would be typing it into the chat interface if you were doing something small. Here, that's just replaced with a spec. But the spec has overall context, which a chat window might not have. So it knows exactly what to do, what not, why, what the priorities are, what the non-negotiables are, what the edge cases are. So the implementation becomes almost easy. It's not the hard part.
And in terms of that spec, has there already been something like an application architecture that has been defined there, or is that left to the AI agents to actually determine?
No, this architecture would definitely be in the spec as well. Unless you were doing a prototype and trying 3 different architecture approaches to present them to the client, maybe, or running them side by side to see which was faster, something like that. If you can in the spec define your architecture, you will. Because often the choices in the implementation, the coding framework, maybe even the language, all depends at implementation time on that architecture. So it's,
I guess this is where we're also going. Yes, and anybody could perhaps pick up the process in terms of spec-driven development. But if you have the experience in software engineering, you're probably thinking through all these other aspects and you're incorporating them early on into the specification in order to better guide the outputs. Yeah.
yes, absolutely. This is why the spec-driven development, not by definition, but at least in my experience, benefits from having a developer involved from the very beginning to the very end, a senior experienced developer. Because as you said, a lot of this will be stuff that's in the back of your mind already. You just surface it. You move the thinking to the beginning of the process rather than in your head as you go, which is sometimes difficult to do. It's a discipline. You have to realize that you are going to have to think hard about this up front, and that you might have to throw some of those initial decisions away down the line, but that doesn't matter. Agile makes it, I mean, AI makes it infinitely more possible to be agile. You can turn on a dime. If the architecture needs to change, no longer matters. You just create another task to rewrite it in a different way to match a different architecture. You tear down the old architecture and you spin up a new architecture and you deploy it. Makes all of that far, far easier, and so far more fun in any case, because you learn as you go along.
I guess the interesting bit is probably something that you mentioned in passing right at the start, is that while spec-driven development makes it possible for a team of one, more than likely when you're developing enterprise and business scale applications, you're probably going to have a team of people taking ownership of the spec in order to have all those competencies properly reflected and driven into the document that you're creating.
Yes, absolutely. And in this case, this is a WhatsApp bot. So there's a back end, there's a front end web interface, and then there's a chatbot interface. And the one thing that the AI suggested, which was a great idea, was because integrating with WhatsApp with Meta's interface can sometimes take 4 weeks. You need a business account, you need approval, they need to understand what messages you'll be sending and approve them, etc. That can take 4 weeks. So you can't wait 4 weeks. So one of the spec requirements was spin up a fake WhatsApp interface and API as part of this app, because it's well documented. We know exactly what input and output will look like. So one of the tasks was to generate the third component of this. It's front end, back end, and a mock interface for WhatsApp, which gets generated in a minute or two. And then you could use that while you're going through the business process of signing up with Meta.
So there's all sorts of efficiencies and higher velocity that's going to start to show up if you're adopting spec-driven development.
Yes, absolutely. And you could split teammates. Certain teammates could handle those various components and guiding the agents through those components and doing the code reviews in parallel if you wanted to go even faster. You can still slice and dice.
Right. Well, I'll stop interrupting for a little bit until my next question arrives, and I'll throw it back at you again.
Yeah, this is just the Git log, and you can see, I mean, one of the AI can help you with your commit messages as well. So nothing gets lost. You have a running, this is over 2 days. This is the entire beginning to the end, from the scaffolding at the very beginning at the bottom, all the way up to doing a proper security audit with a more expensive model at the end, just to make sure everything is there. And one of the things I recommend you instruct the agents is every time they finish a piece of work, they commit the code, so that you've got a working example of a working piece of code at every stage. And if any one of those tasks falls short, you can go back and have a look and see what happened and tackle it separately. But you've also got a documented history for someone in the future to see what was implemented when in each version of the software. It means nothing gets lost. A new developer can join the team and pretty quickly get up to speed on context.
So perhaps I'll just ask you, Ewan, just in your environment setup of what you had, what was the collection of tools that you were working with? So far, I'm expecting it's something that mixes GitHub. You've obviously got DevOps access as well, and effectively in terms of working with the spec, etc. You were working with Claude, but just what was that tool set stack that you had?
For this simple application, was Visual Studio Code, and everything pulled into there. So Visual Studio Code supports GitHub for checking the code. It pulls Claude in natively for your chatbot, but obviously Copilot is in there as well. It gives you all the options, everything you have available, you can pick and choose. And then all of the files are written by the agent running out of Visual Studio Code effectively. And for you to do the reviews, you do them in Visual Studio Code. It's a nice self-contained environment. I didn't use standalone Claude tools in this instance because it was a slightly smaller application, but I'll get onto that with the other application, which is a much bigger beast. And then you bring in a variety of other tools.
Great, thank you.
But you're not constrained to anything. If you're allergic to Visual Studio Code, there are an infinite number of options and possibilities from every big company out there. They all have them. You can pick and choose. You can swap and change. If you're a command line Twindy, you can do all of this from the command line. Entirely up to you. Whatever makes your team more efficient or your team member more efficient. Okay, and then, for example, tracking the architecture of the system. Basically, my approach at least is to create markdown files. We'll talk about that for the more complicated app as well, which are just text documentation within the repository. So they sit next to the code. So every time you commit a new version of the code, you effectively commit a new version of the documentation as well, which is great. So you've got a working record of every decision made. And an additional benefit of documenting code inside the repository is if you pick up the code with AI after a day, obviously the AI has no memory of what you did yesterday. Its context is long gone. It needs to familiarize itself with the code base and the decisions and what was done in the past. If you've documented your decisions in the code in Markdown, for example, which AI is particularly good at reading and understanding and updating, then it has an instant way to jump straight into the context without reading through every line of source code, which is slow and expensive. There's also other ways, many other ways and other tools to improve that process, but we won't really go into those today unless anybody specifically asks.
I find it amazing that with this amazing new technology, we've been reduced to raster prints that look like dot matrix outputs.
If for presentations you need them, you just ask, and it will convert these into HTML with beautiful diagrams and spiderwebs and charts and whatnot. That's the other thing, is you don't have to worry about the documentation. If someone's allergic to HTML, you want to give them a PDF, no problem. If you want to consolidate all of it and summarize it for a non-technical audience, you can do that after the fact, because the AI already knows the full context and is extremely good at summarizing things for different audiences. So it makes sense to pick the simplest solution in the beginning, and you can go from there wherever you need to.
So our development is not going to be held up by needing a printer ribbon?
No. Or anyone to print, or anyone who says my PDF reader is broken, or I need a document that I can edit, or Word is not my thing. I'd rather just have straight HTML that I can load in a browser. I mean, we use them all on a day-to-day basis, depending on the client and the audience and whatnot.
Fantastic.
Okay, so I will show you very briefly. I'm just, how are we doing for time? Okay, I'll show you very briefly. I will stop sharing the presentation.
What Ewan's currently doing is changing the printer ribbon on the dot matrix printer. Still discussing moment, so as he spreads that across the
I'm trying not to
the printhead.
break teams.
Can't believe you didn't write a spec for this. You and you'll have it automated.
I've got too many windows open here, but I will. Geez.
While Ewan's busy with that, I'll just remind folks that if you do have a question, then just log that for me, please, either in the Q&A function or under the chat function, and I will close up there.
Okay, with any luck, you can see my shell window.
We can.
Okay, so I've got, as I mentioned, this app has 3 parts. So there's the WhatsApp API. So I will just run that. That's the mock WhatsApp API that we're using locally. Then there's the backend. And these are all kind of kept totally separate and nice and easy to run in isolation and debug and hand to different people if you need. And then the front end. So now this is going to open a browser window, which I will then have to switch to as well. But I'm getting more familiar with this. Okay, there we go. So this is what the front end looks like. So there are no reports, so it fails at the moment, but this is if you want to grab reports and statistics, and it has full OAuth authentication and login for users that are in the MySQL database in the backend. There is only one, me at the moment, and I can sign out and sign in. So that's the application side of it. And then back to my terminal, I can quickly show you the WhatsApp chat interface.
And of course, for all our well-versed AI people out there, yes, it is possible that Ewan is running a deep fake on you and that these are all just screen generated at the moment from an AI perspective.
Absolutely. Well, I've got all the tools to do it. Okay, so this is the WhatsApp mockup. So user on the floor, and because our spec was great and we're making this as easy as possible for the users, I want to report a near miss. So I'll pick number 2 and then name and employee number, and you follow the process. And then it literally guides you and walks you through a well-defined, quite simple process. In this case, because it's a near miss, not uploading an image, but it also supports loading images. And those images are stored alongside the database with the actual data that you've entered in the database. And then voila, you'll be able to generate statistics. So that's basically an app. And yeah, this took me 3 days from start to finish to get up and working. The only piece left is actually deploying it into the client's environment. And even there, that's a separate topic entirely, but I can help you with that.
So just in commentary around that, even I take it like 3 days in terms of working with it is certainly not necessarily reflecting all the thinking, etc., that goes on around that. And certainly it now poses a different dynamic in terms of how you work with the customer. You'd be showing them prototypes and you'd be showing them walkthroughs that much faster in terms of what would normally have been the case. And once that happens, does that then introduce the opportunity for feature changes and more refinement towards what they're going to get value from, I suppose?
Yes, definitely. I mean, those 3 days, the majority was writing the spec and writing the task definitions and the edge cases and thinking through it. Actually writing the code, about 80% of that was done by AI, and then the other 20% was me reviewing the code and making small changes here and there. So you're absolutely right. You can now give this to a client, as I just did to you. I can mock this up and we can show it to a client, and they can say, as clients sometimes do, yes, that's exactly what I asked for, but no, it's not what I want. Can you change this? And how about this? And what about this? And we can have an interactive discussion. So you can get something to them in 3 days, which is brilliant. So it's a really short sprint. and it actually does something useful. And you haven't yet had to deploy it into their environment, so you can still make architectural decisions at this stage. If they change their mind and want to host this in Azure, you can do that. That answers the question, I think.
It does.
Okay, so the next application, much bigger one, so we'll skip through it quite quickly. But what it is a RAG system, so a retrieval augmented generation system, chatbot with smarts, basically. So a chatbot that knows something. DVT has one called Ditto, and you can ask it any question about DVT, and it has access to internal documentations in the DVT website, so it can hold a conversation. So in the background, there is an LLM, there's an AI engine that holds a conversation with you, but that engine can't tell you how to make cupcake recipes. And in fact, it's been explicitly denied from doing anything that's not task focused. So we're building on the steps of mistakes other companies have made in the past. And Microsoft have made it very easy not to put your foot in the wrong place nowadays. And basically the chatbot will pull from your specific set of documentation, whether it's PDFs and Word documents and PowerPoints and text files, whatever you have, and websites, and answer questions for you. That's what a RAG system basically is. So we have a previous one that's live at the moment that grew organically into what Ditto is, but we need to upgrade it. We need to use new technologies. We need to improve on the lessons learned from the previous version. So the very first big input into the specification was the entire previous system, the entire source code and architecture and tasks completed and bugs filed and everything else that the old system was is the very first step of the spec. Then what goes into it is architectural changes. So Microsoft have moved formally to Foundry now, and all AI services are under a nice umbrella, which is all well-documented, structured. They all the various pieces play beautifully together within Foundry. So we wanted to use entirely Azure services, no services that were external to Azure, and use Foundry as well, because the purpose of this RAG system, once it's finished, is to go into the Microsoft Azure Marketplace. So it also now has to comply with marketplace requirements, which includes some pretty strenuous Microsoft audits, security audits and architecture audits and code audits and whatnot. So building out the spec took quite a bit longer. But then there was some live documentation as well, and at least we knew and could define it very easily in what it did. Well, because again, this is a single developer serial process. It could have been easily done with a team as well, but it was an experiment. But also infrastructure as code. This thing needed to support full infrastructure as code. One line of code on a command line must be able to provision an instance of this, because it's multi-tenant, inside Azure, deploy the resources, and then build the code and deploy it into the resources you just deployed in one line, which it does nicely and easily. AI is very good at that. I used Claude Code Desktop to do most of this. So it's a nice environment for controlling sub-agents and doing spec-driven development. Visual Studio Code or your IDE of choice is still there to do the code reviews, but pretty much everything else I did in Claude Code. I will show you an example of what that looks like, because I've got a saved Claude Code as a snapshot, just so that I can show you that I'm not faking this.
Like these days are very convincing you.
Yeah, makes demos easily. So this is Claude Code running on my machine. This isn't a screenshot, it's the actual thing. So you can see what it looks like. There's the very first kind of initial prompt that I gave it to kick things off. Could have obviously been a lot better, but I gave it a RAG on Azure guide document, which was my thoughts and constraints that I knew, as well as some of Microsoft's guidelines. Pointed it at the vector search app at the bottom here, which is the name of the previous application, and literally suggested switching from C# to Python. A, I'm more familiar with Python, and B, Microsoft's reference architectures for RAGs are often in Python as well. And then, yeah, reusing everything could be, and then ask it as a first step. You can see break down the functional pieces of the current application as a start point. And this was the start. This is the way I approach it. This doesn't mean it's necessarily the way you might approach it. Be different for everybody, what your experience is and what you're trying to get out of this. But the point is, you don't have to get it all right. It's an iterative process. And yeah, I was using Opus at this stage, and it very quickly breaks things down into components. And then we go through, I read these and we have a discussion. So then I try and get it to stop designing the new one, and let's just document the current application end to end in a markdown file so that we've got a reference starting point for the future, which it then goes and does. And then I break down the pipeline so I can understand how those work. I ask some side questions about the right way to do things, something that I didn't know, and it quickly fills me in the architecture. So I'm learning as I go along as well, which is great. Some high level questions, and we discuss about storing stuff. You can see how it goes. This is a long discussion. And then we start designing the project structure and creating the repo and all the basics, and literally taking it down, breaking it into specifications. So what I did was I broke the overall version, since this is a big application, there are a lot of moving parts, into a specification for infrastructure. We'll just list them. So there's a specification for infrastructure for the ISE stuff, one for ingestion of documents, uploading them into the system, one for querying them, one for the API, the endpoints, one for actual deployments, and then one for querying and one for the front end. And all of those became separate specifications. But the system can, yes.
Did that come about because you were anticipating basically wanting to isolate these elements from future changes and updates, so that you would kind of go, all right, if I'm focusing on X piece of this application, there's a specification for that, and then obviously related tasks and then resulting code from those. Is that a better sort of technical approach or design approach to using SDD?
It is, in my opinion, because for one, you're helping your AI sidekick along because it has a spec for a piece. So AI context is limited. A, it's expensive, and B, it comes in and out of context. So you don't want the system to be thinking or have to be thinking about the entire end-to-end solution, front end, back end, this flow, the architecture, everything all at once when you're focusing on one piece. So if it's a project like this where it splits nicely into logical bits that are in many ways independent from each other. For example, I can design the ingestion side of things first. So I can upload documents, pull them apart into tokens, store them, vectorize them, and get them ready in the database for queries before I've written the query engine or the front end to interface this, because I'm running it from the command line in the beginning. That's a perfectly good way to start. And then, as you said, you've got a running history of each specification in isolation as well. When you make a decision, that gets included in the spec. When you decide not to do something you originally decided to do, that lives in the spec now, and you have a walking history over time of what you did. So it's easy enough to, if you're bogged down in a particular section, you can call in help. You can say to a colleague, come and help me with this particular section. Here's the specification. Don't worry about the rest. That's all in hand. But this is the spec you can use.
Which also goes towards answering a question that Armand had, which is, in your experience, can team members work simultaneously during the SDD stage? And I take it from what you just said, if you're decomposing your set of specs into these different areas, that is very much the case, provided, of course, you're bringing that all back together in terms of the project.
Yes, absolutely. You still have an overall spec to pull it together. People are reviewing it, and you have to talk. There's no avoiding that. You have to make sure when you deliver something that you let everybody else know. But your own unique skills and experience can come into play. If I'm not a front-end developer, thanks to AI now, I can fake it excellently well. And I can spin up mockups and interfaces that might look great, but there'll be initial functional demos and whatnot. But if there's someone who is a designer and a front-end developer, by all means, let them design the front end with the help of AI, and they'll do a far better job than I ever can. So play to skills. If you're an infrastructure person, they can take the infrastructure as code setup part and the architecture deployment part, and probably do a better job of it. So absolutely.
And just being familiar with the prior product and how long we had worked on that was probably a 6 to 9 month project in terms of some development work being done in order to get to the product we eventually had. Was there any reuse of the code assets that were actually in the existing application, or was it a conscious step to go, I'm going to use effectively the code and the project that existed as an input to defining a spec, and then I'm going to consciously then drive out a completely new code base based on that spec?
Mostly the second, but it's never quite that well defined. There was logic that was reused, and assets in Azure that were reused because we knew them worked already. But yes, it was rewritten from scratch because, as I said, the first application was organic. So it didn't grow. There wasn't a master plan in the beginning. It grew piece by piece, try something, it didn't work, try something else, find a cheaper option, tweak the model size a couple of times to get the costs down and work with the documents, that kind of thing. Those were all valuable lessons and those were all pulled in. That's why I started referencing the existing code base and all the documentation around it. But mostly it was a clean rewrite because the foundation was Microsoft's reference architecture for something that they are going to approve when you try and get it approved and audited for the Azure marketplace, which the existing app would never have passed.
Got you. All right, great. Thank you.
Yeah, and we've got it to the point where this did now pass the first architecture review, first pass, which we're quite proud of. But it's nice and tangible. And okay, so next piece basically in the presentation, I think, would be demoing the application itself, because the next step is the front end. The front end doesn't exist right now, but I will show you that the RAG system itself works from the command line. Let's put this on the screen. Okay, can see it right?
Yeah.
Okay, so this is an example. This does take about 15 minutes. So I did it earlier, but earlier today, just to make sure I'm not cheating as well. So this was a deployment of the architecture to Azure. So it was a single command. Well, once I've logged myself into Azure, so it knew who I was and what subscription and rights I had. Because this is an infrastructure as code first project, single command line AZD up, it deploys the architecture to Azure, and you can see the various pieces. It creates a resource group and puts all of these services into it. It deploys them, tests them, starts them up, gets them running, lets them talk to each other, and then goes and builds the application in the cloud and then deploys it to the just deployed infrastructure. So it didn't actually take that long. It took 2 minutes, 9 seconds to do the provisioning, and then 3.5, call it 4 minutes to do the actual deployment. Gives you an endpoint. And then what I can do to prove that it's actually working is if I call the health endpoint, with any luck, it'll come back and say it's healthy. So one of the things we've done is set this to scale to 0. So the Azure resources, when they're not being used, they basically scale down to 0. So we stop billing. So it's super important for a dev environment. You want it to be as cheap as possible. But it takes a while the first time you call it like this to spin up the first instance. But it is properly scalable. And then while we wait for that, if it's going to take a while, above I've shown calling the query interface and asking an actual question of the LLM, basically. Okay, so there's the health status, and if I run that query again, I just pass it to the chat endpoint. So I asked it, what technologies does this project use? Because my test data is, ironically enough, the specification for this application, because it was the simplest documentation with a bit of complication and multiple docs that I had at hand. And it answers, basically, the one-liner that you'd give to the user in the chat interface. So it answers the question nicely, and it gives you a reference to a particular document, because all of this came from the README Markdown document. And then it matched it 1, 2, 3, 4, 5 times to answer the question, and it gives you a confidence score for each of those matches, and then references the top confidence score as the top one. So it actually works, which proves that the ingestion worked, because I had to upload those documents. It proves the architecture works. It proves that the LLM is behaving and doing its thing. And if I ask it something like something out of its guardrails, like what's and pass that as a query and then call it, it's going to, with any luck, tell me very politely to go away. Okay, so it short circuits the whole process. It doesn't even go to the LLM. It works out that your query doesn't match any of the documentations and literally any of the documentation, and literally says, I don't know. So it's still referencing a particular documentation, but there's no citation, so you wouldn't link the user to a document. There's nothing in there that would be of value in any case.
The degree of politeness we'll leave at, yeah, lukewarm.
Yes, this is just me. So you can make it smart, but this is a one-liner. If it knows upfront, obviously, that what you're asking for is not relevant, it doesn't even need to call the LLM, which is the single most expensive call in this application in any case.
Which ones have been some of the considerations in building applications that do leverage LLMs as part of the intelligence is knowing when you can use cache augmented generation and RAG pieces directly versus having to get a content piece generated and returned by the LLM itself.
Exactly, particularly if it's a public interface that the world can hit and nasty people can hammer and try and abuse. That's exactly right. And we want to use a model that's good enough to have a proper conversation and sound decent, not to sound like a terrible support bot that we all hate, but cheap enough as well.
But if you want a terrible, horrible, traditional bot, then I'm sure other companies can build that for you. But a DVT, no.
No, we need a decent experience. We have customers who come to us because they've gone for an experience that's suboptimal and annoys their customers as opposed to actually doing what it's supposed to, which is helping them along. So just making sure I've covered everything in the list, but that's pretty much it. It was a much bigger application. Again, it was just me, so there was no real chance to be done in parallel, but we got it to where it needed to be. I learned a lot. My opportunities were learning Foundry properly, which was one of my goals going into this application. I'd run test applications against it, but never used Foundry as an end-to-end application solution environment, which it really is meant to be. And it's brilliant. Thoroughly enjoy working with it. So as a developer who's steering this kind of project, not only can you produce code in a week and get it to an interesting level where it's actually working, but you get a chance to learn along the way with an AI agent who can really help you along and guide you and fill in the gaps in your knowledge and your skill shortages and things like that.
You explained the process in terms of the new code base generation out of it and reuse of some of it. Were there any concerns about technical debt inheritance, given that there was an existing system that you were looking at?
Not in this case, because that was one of the inputs into the decision to start with a brand new code base. So, and the better your spec, the less technical debt you'll incur in the beginning. Obviously, it'll come along, but you need to be careful. But since you have a spec that's next to the code and you work very hard at making sure that spec doesn't drift away from the code, that the two are in line, technical debt is something you can manage now and tackle far easily and at a quicker pace than ever before.
So definitely one of the benefits that's going to be derived out of these new processes.
Definitely. Okay, and then one of the topics for the presentation in any case was who owns the code, and the obvious answer is you do. There's no negotiation. We don't really need to go into it much. As a developer, it doesn't matter whether AI spits out 1 million lines of code. That code is your responsibility. AI cannot take responsibility for the code. It's a machine. Who's going to be called at 2 in the morning when something key breaks? It's going to be you, not the AI. You need to review the code. You really do. There's no way around it. It is incredibly tempting to just trust the AI. And you do get into a place where you trust it because it's done consistently good work for a long time. And then it will hallucinate something for a good reason, but something you might not see. You have to review the code. It is still your code, your responsibility. You are accountable for it. You make decisions along the line as well. This is not autonomous. You made some of the decisions in the spec, but you make other decisions as you go along. Yeah, so just think about it that way. Whoever ships owns. Decisions are authorship, and so you are the author really. And when it breaks at 2 a.m., who gets called? It's not the AI. Key takeaways. So yeah, SDD is not new. It's just infinitely more attractive and usable and beneficial in the world with AI where we find ourselves. Whether we like it or not, AI is there. And many traditional frameworks do not adopt AI nicely. SDD is one that very much does. AI amplifies whatever's in, garbage out, moves the thinking to the front. Some people don't like to hear that. It's a good thing in the long run. And speaking as a developer, content economics matter as well. If you define the spec, then the agent doesn't redo something 6 times until you're happy with it, which costs money. Tokens are not free, as we all know. You own the code, and then developers aren't being replaced at all. Developers are essential in this process. You can bring what you know already, your experience. Yes, it's going to be tougher for more junior developers to upskill rapidly. But again, this kind of a system can help you with that upskilling in a way that you never would have had before.
Great stuff. You. I'm going to ask our audience again, if you do have questions, please just drop those probably into the chat. Is probably most useful for me because I can pick those up quickly from there and pose those to you. In the interim, Ewan, while the folks are thinking of those very hard questions, or alternatively, they're asking Claude or Gemini or somewhere else for a question that will stump somebody around SDD. Just from your experience, what would you say was probably the most useful thing that got you pointed in the right direction with SDD?
I suppose having tried it in the past, the traditional way was one thing that helped, and seen the benefits. So I already knew it could help in a traditional environment in some cases more than anything else. And then, at least in my experience, has been making mistakes. So diving into a project with AI, but the AI produces rubbish because I'm not defining what I need to as fast. I'm not keeping up with it. I become the bottleneck, which gets very frustrating. And you want to be able to tell an agent, go off and write this API endpoint for me. In fact, write all 6 of these while I research Foundry and choose the architecture for the next step that we're going to do. You want to be in that situation. That's a pleasant place for a developer to be. You no longer have to do the boring legwork. You define it and you let the agent go. It'll come back to you if it has a question to ask. But otherwise, you can move on with the thinking parts, the architectural parts, the learning parts. And the fact that you can just get something to a client very, very quickly is amazing too, because we all know that from Agile, at least, that's one thing that you can't really argue with. The faster you give the client something to review, the better the end result is going to be.
And you did raise it, so garbage in, garbage out. But what else would you say are key risks to watch out for in terms of adopting SDD? Is there anything particularly in the technical level that you're going, if you don't look after this, then your downstream assets that you produce in the code side of things are likely to have issues? I know as one note, you had consciously addressed the security and testing aspect of things.
Don't vibe code stuff. If this is out of your experience level and you've never written an application like this, then maybe rethink the process. Maybe you're not the right person to be writing the spec. Maybe you need to bring other people in. You use your previous experience to do this kind of thing. It helps to be a senior developer. You don't need to be an architect. If you are an architect, you have a lot to add to this kind of thing. If you're a business analyst, by all means, you have an infinite amount in the very beginning to add, which can simplify things immensely downstream. But you do have to think about it. AI makes incredibly plausible, well-argued, reasoned decisions which are insane because they make no sense or they don't fit with your environment, which the AI does not know anything about. You need to treat it like a colleague who is incredibly smart but has never spent a single day in the real world. They don't know how to drive cars or what trees are or why your boss messages you at 3 a.m, or they don't know any real world context, which definitely impacts all of these things. If I'm focused on client centricity, for example, I know my client well because we've done work for them before. I can add a lot. I can say that they're cost sensitive. They are not technical. So don't involve them in the technical questions. Or if you are making a decision, tell them why and ask AI to list the pros and the cons, to weigh them up and to estimate the relevant costs so that they understand it.
Right.
So,
and then I guess the one thing I would want to check in with you again is to go, would you go backwards to the traditional way of developing and coding, or is this now it?
yeah, no, that's an easy one. This is definitely the way. I'm thoroughly enjoying the AI revolution. It comes with its own challenges, but the benefits so far outweigh the downsides for me.
Well, I think in terms of the outputs that you're producing at the velocity that they're coming out, it all points towards that experience and understanding of development process combined with the new tool sets and approaches. is the winning criteria. That's what the new AI build teams are about. That's what new software development life cycles enhanced with AI are really about. You can't put that too simply to go, it isn't something that you should just do without conscious knowledge and experience to reference in regard to software engineering itself, data engineering too, and then the approaches that actually produce meaningful, valuable outputs, I suppose.
Yeah, speed is not enough if you're not producing good work. And if you harness those two together, then you can deliver incredible things very, very quickly. And you don't have an option. Everyone else is doing this. Everyone else is speeding up. If you don't, you will very clearly be left behind.